Let's continue looking at normal distributions, and we're going to do a lot more with them in the next few sections, and this section is focusing on finding probabilities. When a random variable x is normally distributed, you can find the probability that x will lie in an interval by calculating the area under the normal curve for the interval. And I've mentioned this a few times, but it's really important. And the area under the curve is the same thing as the probability. So in the last section, we were finding these areas, we were actually finding probabilities. So those two ideas can be interchanged here. If you know the area, then you know the probability, and vice versa. So let's do a couple examples. A national study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. A college student with a job is selected at random. Find the probability that the student works for less than 4 hours per week. Assume the lengths of time of college students' work are normally distributed and are represented by the variable x. So, normally distributed. If you see normally distributed, we're thinking that bell-shaped curve. So, the first thing I'm going to do is draw a picture here. And I'm going to use my x values first. And x values were hours, right? Talking about hours worked. So if I go back through my information, I see that the average number of hours worked was 22 hours in 1 week. So my center here is at 22. And the standard deviation is 9. So I don't need to put that on my graph necessarily. I'm just going to make a note here. So my mu is 22. My standard deviation is 9. I want to find the probability that a student works for less than 4 hours per week. Okay. So if my mean is 22, think about where the number 4 would go, right? 4 is less than 22. So it doesn't have to be perfect, but maybe it's like right here. Okay, let's do that in green so you guys can see a little bit better. And I want less than 4 hours. So the part of the curve I'm looking at is this over here. Right? So I want less than 4 hours. So the area of this is going to equal to my probability. So area and probability, same thing, okay? Now, if you're using technology, this can be really fast. So if we're using technology, then just like in the last videos, we're just going to use that same idea, second bars, and then you're going to connect that normal CDF piece, and you're going to do your lower bound, your upper bound, I'm running out of room here, bound, your mean and your standard deviation. So in this example here, right, now my lower bound would be negative 99999, right, because it's going to keep going to the left. There's no cutoff there. My upper bound for the shading is at 4. My mean is 22. And my standard deviation is 9. All right, so let's see what we get. All right, so second bars, normal CDF. All right, my lower bound, negative 999. Make sure you're hitting the negative button at the bottom here too, not the subtraction sign. My upper value is 4. My mean is 22. And my standard deviation is 9. And when I hit that, I get about 0.022751. And let's see, your book looks like they use 3 decimal places here. Actually, no, they use 4, excuse me. So we're going to let this be about 0.0228. We're rounding to 4 decimal places. So if you're using technology, then you have the answer. That would be our answer here. So the chance of someone working only less than 4 hours per week is going to be 0.0228. So just as a side note here, this would be unusual, right? Because it's less than or equal to 0.05. So if most students work on average 22 hours a week, it'd be very unusual for a student to only work up to 4 hours a week, right? So this is very small. If you want this in percent form, you can always multiply it by 100, and you would see that about 2.28% of students work less than 4 hours per week. So it's a very, very small number. So it would be pretty unusual. Most students are going to be working more than that. Now, if you're not using technology, then you have to convert to z-scores. So you can use your table. Okay, so if you don't have technology at home, or you don't want to use it, you're not interested, that's totally fine, but you do have to convert this to z-scores, because that table in the back of the book that we talked about in the last few videos is only for z-scores. It's not for any x values, so we're going to change over, but we can do that. So what's going to happen is your graph's going to look the same, but our center is going to be at 0. So remember, when we convert to z-scores, we're using the standard normal distribution instead. So your mean is 0, and then I'm just going to make a note here that your sigma is 1. And again, we're looking at z-scores here, not x values. Now we can change over. So how do I figure out what my corresponding? So the picture is going to look the same thing as above, but instead of having an x value here, I need it in the z value form. Okay, so again, I'm drawing the same picture, but I can't have x equals 4. I need to have a z value there. So the formula is x minus the mean over the standard deviation. So my x value was 4. My old mean was 22. And my standard deviation was, see it, was 9. So when we do all that out, we actually get the exact value of -2. So our z value here is -2.0, or -2 is fine. Now, if you want to use technology at this point, you can as well, although, I mean, if you're going to do z-scores, you might as well use the table, but you can still use technology here. So if you wanted to do the rest on technology, I'm going to skip this on the video, but you would just do that normal CDF. And when you write everything in, just be careful. Your score here is now, instead of 4, it's going to be -2. And then your mean instead of 22 is now 0, and your standard deviation is now 1. And you'll get that same approximate value here. Okay. Now, if you're using the table, let's show you where that is. So notice my shading is going the correct direction, first of all, right? So it's nice for the table. And I want -2.0. So here's -2.0, and I do need to make sure that my hundredths position is also 0 as well. So I'm going to scroll down here and find my matching value. And what's going to happen is I get -2.00 corresponds to 0.0028 for that probability. Sorry. See that again? 0.0228. From the table. So we get that same exact value here, but using z-scores instead. So you have 2 ways you can do it. If your question does not ask you to find z-scores, if it just wants the answer, then using technology is pretty quick. I would just draw that picture and use your technology. If the question wants you to convert to z-scores or asks you for z-score values, then you're going to have to do that conversion over. And then you can either use technology like we did before, or you can use that table to quickly find values for z-scores.